The Cube and the Tesseract. Hello, inquisitive minds. I think most of us know what a cube is. Just as a refresher, a cube is a solid composed of six square faces. We can also count the intersections and edges, but let's just stick to faces for now. The basic unit of a cube is a square, which is a plane with four equal sides. However, a square is also what we see if we look at a cube from an orthographic projection, or simply said, if we view the cube from the top looking down. But unless we have this or this in our hands, this drawing is a two-dimensional picture of a cube. Technically, it's not a cube, but it is drawn in a way that our eyes perceive it as a picture of a 3D object, and in this case, a cube. We can convey a stronger illusion of a cube in a 2D space like a paper or a computer screen by using color, light and shade, or motion. However, in math, a cube is also an exponent where a number is multiplied by itself 3 times. For more information on exponents, please see the link in the description below. A square is a number multiplied by itself twice. In this example, 4 squared equals 16. And a cube is a number multiplied by itself 3 times. In this example, 4 cubed equals 64. In 2D, two sides usually define a plane or an area, multiplying length by width. While in 3D, three sides usually define a solid or a volume, multiplying length, width, and height. So what is an analog of a cube in the fourth dimension? It's called a tesseract. Now that word sounds familiar. Where did we last hear that word, tesseract? Oh yeah, there, where the bad guy zapped half of everybody to another dimension. Let's get back to the real tesseract, which was coined in 1888. So what does a tesseract look like? Well, it sort of looks like this, glowing blue color optional. I say it sort of looks like this because we are 3D human beings, so we have to stretch our brains a lot to visualize the fourth dimension. That's okay if 4D fries our brains. Let's just try to grasp the concept using comparisons. If a square has 4 equal sides and a cube has 6 squares, the tesseract should have 8 equal cubes. If we go back to a cube, we see that while the cube has 6 squares, we only see 3 of them at a time, especially on 2D. We just imagine the third dimension. So if we use this analogy for a tesseract, we should only see 4 cubes out of the 8. Now on 2D, like a screen or a piece of paper, we can create the illusion of a 3D object of a cube. But depicting a tesseract on a 2D surface is a stretch, so this is a rough approximation of a tesseract. Much like the 3 sides of a cube, which we don't see but we can imagine, there are 4 solids of a tesseract that we don't see at any given time. Since on paper or on a screen we're only imagining the third dimension, a 2D analog of a tesseract will force us to imagine 2 dimensions, 3D and 4D. In addition, perhaps a better way to visualize a tesseract is to make an actual 3D object of it, and maybe it has to be in motion. Again, it's okay if we can't totally visualize what a tesseract looks like, for as long as we come close to the concept. It's like an ant walking across a surface and someone picks up his compadre in front of him. To the ant, his bro has suddenly disappeared from his plane of existence, but his bro just got lifted off to the z-axis. Well, technically, almost all ants are females, but you get the point. Now what you see here is an amateur representation of a tesseract. The math dudes have the tesseract nailed down to drawings, animations, and computations. You can find it elsewhere on the internet for more mind-bending. But before we exit this video to go watch more cute kittens, let's stretch our imaginations a little more. A square is four lines that are connected to each other at a point. A cube is six squares that are connected to each other on every edge. In theory, a tesseract is eight cubes that are connected to each other on every face, not only on one face, but on all six faces. Can we imagine that? Again, that's eight cubes connected to each other by all of their six faces. It's mind-boggling, but that's alright. We come from a 3D world. However, if this is a square and this is a cube, shouldn't this be a tesseract? Shouldn't we call an exponent to the power of 4 a tesseract? How about calling it a Thanos, a Loki, a Doctor Strange? My vote is on Doctor Strange. The number 3, Doctor Strange equals 81. What's your vote? Thank you, and please comment, like, and subscribe.